Good afternoon to all the students. So here we are come to the end of fourth module. So the some of the problems I'm giving two problems today to understand. After that, you need to work with the example 7.9 and 7.10 and 7.11. These three are the problems as a homework. You need to do that. Okay, so that you need to complete by before the next class. So today only you try to solve those problems, go through the problem. Three problems I'm giving after this. Or if, during the class time, if you're having time, you just go through it and solve it or try to understand what it is. Now, today we'll see the second problem of today's. Sketch the body fluid for the following transfer function and determine the system gain crossover frequency, phase crossover frequency, gain margin, phase margin. Also determine the value of K for a phase margin of 45 degree. So this is a typical problem. So this is 7.8. Now G of S and H of S, AT into S plus 5 divided by S square into S plus 50. So here zeros as well as poles are there. Now for the given G of S into H of S, the sinusoidal transfer function is, you have to convert S into J omega. So G J omega, H J omega is equal to AT into J omega plus 5 divided by J omega square into J omega plus 50. Now the sinusoidal transfer function in time constant form. So we have to get a 1 plus. So here 5 you can take it outside and divide by 5. Denominator 50 you can take it outside and divide by 50. So 80 into 1 plus j omega by 5 into 5 divided by j omega square. 1 plus j omega divided by 50 into 50. Now 80 into 5, that is 400 divided by 50. So it will get you will get a 8 into 1 plus 1 by 5, that is j.2 omega divided by j omega square plus 1 plus 1 by 50, that is equal to 0.02 omega. So you, after finding it, you got the transformation like this in a time constant form, and in it it's also sinusoidal transfer functions. Now we have to identify the factors here. Here 1 0 is the then poles, multiple poles at the origins and another pole. So here we can say that one is 8 divided by j omega square, one factor. Another is 1 plus j.2 omega. Next one is 1 plus j.02 omega. So the first one, it is, as you know, that the term of factor is 8 by j omega square. Then other factors. Okay. Now we will see the factor 8 by j omega square, then 1 plus j.2 omega, then 1 divided by 1 plus j.02 omega. The corner frequency is here, first term is none. For the second term, it should be 1 plus omega t, and corner frequency omega 1 is 1 by t. So here t is 0.2. So you will get 1 by 0.2 is equal to 5. And third one, it is in the form of 1 divided by 1 plus j omega t. So here t is 0.02. So omega 2, corner frequency is 1 by 0.02. You will get it as 15. Now here 8 plus j omega square, 8 by j omega square is a straight line of constant slope of 1 divided by, so it is minus 20n. So n is here 2. So it is equal to minus 40 dB per decade passing through the at omega 1. In order to find that, you have to find 20 log 8. 20 log 8 is equal to 18 dB at omega is equal to 1. If it is 1 divided by j omega square, then it exactly pass through 0 at omega is equal to 1. Now here the phase angle minus 90n. So here n is 2, so you are getting minus 180 degree. So for this second term, as you can see that it is a till corner frequency, it is 0. After that, it is a straight line with a slope of plus 20 dB per decade after the corner frequency, because it is a 0. So you are getting straight line of 0 dB for omega less than omega 1 is equal to 5, and a straight line of slope plus 20 dB per decade for omega greater than omega 1, that is equal to 5. Now when you are observing the phase angle, you can see that phase angle varies from 0 to plus 90 degree, because it is a 0, and at corner frequencies plus 45 degree. Now what about the third term? Third term is a pole term. So here a straight line till corner frequency. After the corner frequency, it is having minus 20 dB per decade. Now phase angle varies from 0 to minus 90 degree, and at corner frequency you are getting minus 45 degree. Now you need to calculate the total phase. So pi is equal to 8 by j omega, angle of 8 by j omega square plus angle of 1 plus j 0.2 omega plus 1 divided by 1 plus j 1 divided by 1 plus j 0.02 omega. Now here already we come across that it is minus 180 degree. For this it is plus, it is a numerator 0, so plus tan inverse of 0.2 omega divided by 1, that is imaginary term divided by real term. Third term is a pole term, so it is minus tan inverse of denominator imaginary parts, that is 0.02 omega divided by real part. Now you substitute different values of omega. Omega is at 0.1, calculate the value. Omega is equal to 10, you calculate. Omega is equal to 50, 100, 500, like that you calculate and you obtain. Now you need to draw the now so here as you can see that you have to start from, for the first term it is having minus 40 dB decade and at omega is equal to 1. So you start with the omega is equal to 1, then 10, then 100, then 1000, yes. Now when this is omega is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then like that 11, 20, 30, 40, 50, like that 100. Semi-log sheet. Now what you can see here is at omega is equal to 1, we calculate the value as 18 dB. So here at omega is 180 dB. From there, you need to draw till next to corner frequency. Omega is equal to 5. Omega is equal to 5. That is 1, 1, 2, 3, 4, 5. Till here, what you need to do is you have to draw a line with a slope of minus 40 dB per decade. Okay, till 5. And after 5, for the influence of second term will come to picture. For the second term, till corner frequency is 0. After that, the second term is having a slope of plus 20 dB per decade. Now after 5, before it was minus 40 dB, now it is changed to minus 40 plus 20. So it is minus 20. So here it is minus 20 dB till next corner frequency, that is 50. That is here 10, this is 10, 20, 30, 40, 50. Till here it is again minus 20 dB per decade. So decade means you take 1 to 10, that is a decade. So there, if you are having a 40, you keep the scale from here to here. Okay, you keep the scale in such a way that if you want a minus 40, you keep from 1 to 10, the 40 dB means plus 1 and 40, other end is 0, like that you keep it and slowly move wherever you want. So like that for minus 40 dB. For minus 20 dB means for 1 dB you take a 20 dB of plus 20 dB of or minus 20 dB, then slowly move the scale parallelly. Okay, now yes, after omega 2 is equal to 50, you can see that the effect of after the third term will come exactly after the 50. That means here 10, 20, 30, 40, 50. Till here the third term effect is 0. After that it will introduce again minus 20 dB decade. So the net effect of previous one is minus 20. Again one more minus 20, it will become minus 40 dB per decade. Now correspondingly we are drawing the calculated angle. So you are getting like this. When you are observing it, it never touches the minus 180 degree. So here yes, in this circuit, gain crossover frequency, that is when the gain is crossing the 0 dB, that is gain crossover frequency is equal to 3. That time phase margin is 27 degree. Then next is phase crossover frequency. Phase never crosses the 180 degrees. So you can put as phase crossover frequency is infinity. Phase crossover frequency infinity. And gain margin. So gain margin, there is no crossover frequency. So gain margin is again infinity. Since gain margin is obtained by wherever the phase crossover happens, from that you have to see the difference from 0 dB. You already aware that. So here it is 0, now infinity. Now next question is determine the value of K for the phase margin of 45 degree. So for 45 degree, so the phase margin of 45 degree. So now you see that where you are getting the 45 degree where you are getting on the graph. First, okay, so here it is phase margin. After the original margin, you have to see where you are getting the first phase margin of 45 degree. So here this is the phase margin. So when you are coming here, the difference from 0 dB to that point is 12 dB. So in order to become this as a phase margin, the graph should be shifted up by 12 dB. So we can say that 20 log k is equal to 12 dB. Log k is 12 by 20.6. K is log inverse of 0.6. It is equal to 4. Okay, so this will be very clear, this problem. So like that, you go through 7.9, 7.10, 7.11, 3 problem. You systematically go through and try to understand immediately after this. You take some more time, your own time. So I'm okay, and try to understand. Next class onwards, we'll start our 5th module.